For our physics project, we decided to experiment with vision and how nearsighted people need lenses in order to correct their vision. Let's first give background information on how the eye works to converge light rays to form images on the retina. Here we have a diagram of the normal eye. This is the crystalline lens, and this is an object at the near point distance. So, as light rays come into the crystalline lens, because of the index of curvature difference relative to the air, the light rays will converge and come together to form an image on the retina. Next, we will talk about the nearsighted eye, and we have today our subject, Drew, who actually is nearsighted and wears lenses to correct his vision. Here's a diagram of the nearsighted eye. So a person who has nearsightedness, their lens is too curved, and this provides overly sufficient converging power. This means that an image of a distant object will be formed in front of the retina and then a circle of confusion on the actual retina. A negative lens can be used to correct a nearsighted person's eye. Light from a distant object will diverge as though it were coming from the object's far point, producing an image of the object at the nearsighted eye's far point, allowing the nearsighted individual to see. The focal point of the diverging lens is therefore the far point of the nearsighted eye. Let's prove this experimentally using Drew's vision. Now we are going to compare the far point of a person with normal vision to the far point of a person with nearsightedness. So Maddie has normal vision, so I am going to do an experiment to test out her far point. So Maddie, please tell me to say stop when you can no longer see this object clearly. As you can see, Maddie can see to infinity. Her far point is infinity. Let's look at the far point for a nearsighted individual. Now we are going to measure the far point for Drew. So Drew, please tell me when you can no longer see this object tape measure clearly.
Stop.
He said stop at 27 centimeters. So this is the far point for Drew's nearsightedness. Now we have our nearsighted subject with his glasses on, and these are diverging lenses. So now let's see where his far point is. Hopefully it will be at infinity if his glasses are working. So please tell me when you can stop, when you no longer see the object clearly. As you can see, Drew can now see to infinity. This proves the point that because of the focal length of his glasses, the light rays are able to diverge enough to form a clear image on his retina. Now we are going to perform an experiment to see if covering one eye affects the far point of a normal-eyed individual and someone with nearsightedness. Maddie, our normal-eyed subject, is going to cover her eye, as you see here, and we will now measure her far point. So again, tell me when you can no longer see the object clearly. So we don't have a mirror stick this long, but it's not at infinity. So the converging power of her eye is just not working as well with one eye. We are now here with our nearsighted subject without his diverging lenses. So we are going to perform the same experiment as Drew covers his right eye. So please tell me when you can no longer see the object clearly. His far point is now at about 25 centimeters, and this is 2 centimeters less than the previous measurement. So there may or may not be a correlation between one eye versus two eyes, but it would be an interesting thing to do for further research. We will again now perform the same experiment with Drew covering his right eye. However, now he is wearing his diverging lenses. So let's see how his far point changes now. So again, we do not have a mirror stick this long. However, Maddie's far point was significantly further than Drew's far point. So this kind of tells us that the power of two lenses is stronger than one for correcting Drew's nearsighted vision. Thank you everyone for watching our video. We hope you learned a little bit more about nearsightedness. I'm Catherine.
I'm Drew.
I'm Maddie.
I'm Tim.
And yeah.
Okay.
No, it's fine. Thank you, Dr.
Thank you, Dr. Fuller.
And thank you, Dr. Clutter.